So here we discussed first in previous class we discussed the couple of force. Okay. So what is the couple? Okay. Previous class discussed the couple is a if you want to rotate a body if you want, so need a force. Okay. Suppose if there is a body, we want to rotate that body. Okay. Now we apply the force here. Then body move like this clockwise direction, but in case of rotation, always a pair of forces, not a single force. Okay. Why the pair of force? If that force apply here, some force apply here, another force goes down direction, and these two forces are same. Okay. These two forces are the same, but they are in opposite direction. Magnitude are same, but in opposite direction, and that pair of forces is called couple. Okay. The pair of forces is called couple. Okay. So like consider car range, a key, lock and key, and if you're turning a wheel, okay, cycle pedal, this is a couple. Okay. So that's two forces. These force and these force, the magnitude are same, but the direction is different. Okay. Yeah. Now, if we calculate the moment of couple, the equation, the moment of couple, if you want to calculate the moment of couple, very easy. That is these two force. Okay. So either we want a force, any force. Okay. So if that force, we just consider a magnitude, not a direction. Okay. Here we just class 10, we just consider magnitude. Suppose either one of these force, because their magnitude are same. So that is the applied force and multiplied by the perpendicular distance between the two forces of couple of. So perpendicular distance, suppose these are the called that the perpendicular distance called that's 90 degree and 90 degree. So that is called D is for the force times T. That is called moment of couple. Okay. So here we discuss a new concept is the equilibrium of bodies. What does it mean equilibrium? Equilibrium means there is a force applied but body either moves or not moves. So that means equilibrium are two kinds. Equilibrium means there are two kinds of equilibrium. Either body moves or not. If a body does not move, that type of equilibrium is called a static equilibrium because body does not move. Okay. But okay, the body is rest. Okay. When a body is rest, suppose take an example, there's a table and a body. Okay. So consider a suppose a applied a force applied in downward direction, applied a force. Okay. But if a force applied, huge force applied, uh, same direction, but from Newton third law you know the there is a reaction force also here. This force they cancel each other, so body are in rest. Okay. So if that means a body remain in state of rest. Okay, body does not move. It is called static equilibrium. Okay. And if someone, same example is someone, person A, they pull the body, but another person B, the person A and person B pull opposite direction in the body. So both are applied the same magnitude of force, but in opposite direction. So from Newton's third law, they cancel each other. So that is zero. That is static equilibrium. And what is the dynamic equilibrium? Very good concept. A body does not in static condition; they are moved. It's called dynamic equilibrium. Okay. So when body not a state of rest, body is not a state of rest. In case of dynamic, body is not a static. Body are in motion. Very good concept. Body are a motion. So either means actually here motion means a circular motion. Okay, either there is a clockwise motion or anti-clockwise motion, like this direction. If someone applied a force in that direction, an opposite pair of force in that direction, the body is rotated, like a wheel or paddle. That some example is C or fulcrum or center point here, and some force these or some force down, this force to, but there's two forces here. This body is rotate. Okay, so means the body remain in a state of motion, either translation or rotation, but that is depending. Okay, uh, several forces applied on that body. These are called dynamic, but they are not in opposite direction. If opposite direction, that is static, but in 90-degree or any other degrees happen. Okay, either 90-degree or same direction. Okay, that's also are in body in motion. That is a dynamic equilibrium. Another principle of moments. Next, we discuss the principle of moment. Basic concept. What is the principle of moment? Okay, principle of moment. Principle of moment. Okay, what is the principle of moment? So principle of moment is very easy. That is a clockwise direction and there's a anti-clockwise. So in case of principle of moment, that is a rotational. Okay, that is a rotational. So either clockwise or they are in anti-clockwise rotation. Okay, clockwise or anti-clockwise. So in case of moment, means the body are clockwise or anti-clockwise. So like that, that is sum of sum of clockwise rotation equal to sum of anti-clockwise rotation, sum of moment of, and that's not rotation, that's the moment, and anti-clockwise. No. That is then called a principle of moment. Okay. Suppose there's a clockwise moment is cancelled the anti-clockwise moment. Suppose there's a body here that is called fulcrum point. Some person seesaw like example. The person standing sitting here, another person, a green color person, they sit here. Okay, so if body are in principal monomer body are in state, this force also downward, this force also downward. That is suppose that O, A and B person. So if A into OA, that's moment on left side. If that is that anti-clockwise and that is a clockwise, that is also equal to FB times OB, that is called left side, that is the right side. Okay, that is called a anti-clockwise moment, that is a clockwise moment. So OA means that the anti-clockwise, that is a clockwise moment. Okay, so easy concept here. Okay, that's the principle of moment. Okay, now take an example, simple numerical. Take an example, example of numerical problem. Suppose a rod, consider is 1 meter rod, that is equal to 100 centimeters. Consider if that is fulcrum is here. Okay, suppose that is point C, and that fulcrum point is means that 30 centimeter mark at that. That is 0 centimeter, that is 100 centimeter. Some that weight is suspended, that is equal to suppose weight is 20 Newton weight, and calculate the if body if body are in equilibrium. If body are in equilibrium, what is the weight suspended here? Calculate the weight of this point. It's point A, that point B. Okay, what is the weight of point B? Calculate. Very easy. From a principal moment, we know that 20 Newton left side here, 20 Newton times C2A AC, that is equal to weight of B into times uh, C2B. That is 20 times AC is 30 and weight of B is unknown and CB is 100 minus 30 is 70. So WB is equal to 20 times 30 by 70. Cancel. 60 by 7 means that's Newton. Fraction. Okay, very easy calculation. That's very easy. If someone tells that, take another example, example 2, if told that same 100 centimeter rod or 1 meter rod, suppose Holcomb point same at here, that is a 30 centimeter mark, and one body, suppose there is a weight in that direction. Suppose um, 10 Newton weight downward direction weight, and for the body they are in equilibrium. So equilibrium means the balance each other. This condition also equilibrium condition. Okay, so equilibrium condition. So what is the weight of rod? Calculate the weight of rod. So that is that weight of rod. Let's say. Okay, so that very easy. Calculate weight of rod. If 10 Newton suspended here, a 0 centimeter mark, that is a 100 centimeter mark, and that is a 30 centimeter. Here weight of the rod is that if a full body 100 centimeter, when the which point the weight of the rod is at, that middle, okay, that is a 50 centimeter. Okay, suppose that very easy concept. So that gap here, weight of the rod is suspended here. So that is another rod is here 50 centimeter. The balance the weight of the rod. The gap is now 20 centimeter, and here that's the 30 centimeter. Okay, weight of the rod is balanced here. So 10 times 30, 20 times weight of the rod. Now calculate here. Always important things. The weight of the rod always act as a center. Okay, that's very important. At center point. Not always act as a center point. Okay, important question. Now, if that case of another problem, suppose take example number 3, almost look like a similar of example 2. Suppose here the raw rule, well, consider 1 meter rule or 100 centimeter, and marking point is like 60 centimeter, and a 10 gram is suspended here. Okay, so the G is consider is 10 meter per second square. Okay, mg 10 gram is suspended here. Okay, that is here also. We don't know at the point A 0 centimeter mark, that is a 100 centimeter mark. Now that's the uh, uh, which end must be the suspended end. Okay, so if body rotated in which direction and which end is first. That weight we first previously discussed, weight always suspended at middle of the point. Okay, weight of the rod. So means weight of the rod is mg suspended here. The mass is the weight of the rod. Okay, So suppose I apply the principle of moment here, that is uh, 50 and 6, the gap is 10. This gap is 10 centimeter. So mg times 10 centimeter, now converted into meter. Okay. So one thing is very important. They are in ratio. Okay. First thing, there is a centimeter, but they are in newtons. Doesn't matter, because that principle of moment is almost look like same, because there is a ratio to meter centimeter, doesn't matter. But I think there is a conversion is good if you want to convert it. Otherwise, you get an answer, no problem. Mg times 10, and that is if you want to convert here, no problem, because there is a principal moment that is not here in, because that is a ratio. Okay, so mg times 10, and there is a call, that's 10 gram, uh, 10 gram, also that one doesn't matter, 10 gram, and the answer is also in cgs system gram. And here the gap is now 40, that is 40. So if you consider the mg equal to 40 times 10 by 10, so cancel, so get a 40 gram. Okay, that is m. If that is a consider a mass, if that's sorry, that's consider a weight, not weight, that is a some mass is suspended here, some mass is suspended here. Okay, that is also a mass, that is also considered a mass, that is G, it doesn't important here. That is a mass of rod. Okay, that is 40 gram. Now that is 40 gram here, that is 10 gram here, that means self moment. Okay, very easy concept. That way we calculate. First, where the important point we always choose in class 10 is a 1 meter rod or 100 centimeter, and always the weight of the body suspended at that center, 50 centimeter mark. Okay, and the gap is 50 to fulcrum point. Fulcrum point is given here. If not given here, then calculate the principle of moment. Very easy concept. Okay. Okay. Now here we discuss next topic is the center of gravity topic. Okay. The center of gravity. The center of uh, gravity. What is the center of gravity? Okay, what is center of gravity? Center of gravity means at a point. Center of gravity is a point. Okay, and the point here we algebraic sum of all moment at that point is zero. Okay, algebraic sum of all moment at that point means zero. Suppose that is a no, not a circular object. We consider a rather not abstract object, like abstract shape. There is an abstract shape of it. Here the center of gravity like this. Okay. Now apply the all. Suppose here means force, summon force, apply some force, apply here, some apply here. Okay, some apply here, apply here. Some force is apply here. That is the cause of a perpendicular distance of that. If that the perpendicular of that, okay, that is also there is a perpendicular distance. That is a perpendicular distance. That also perpendicular. So that's moment. That also moment is they cancel each other. Some part plus, some other minus. At that moment, the center of gravity, the all moments at that point, algebraic sum. Very important here. The algebraic sum means the superposition, means the addition of all moment at that point, we get a zero. At that point is called center of gravity. And suppose take an example, if I consider a circle, center of gravity point always at center. Okay, that arrow that point is center. Okay, that's very important. Okay. Because at here, if you calculate all moment at that point, it is zero. Algebraic sum of that point. That is center of gravity. At that point, the body will balance. Suppose see that uh, a point tip and this point, the circle center here. The circle or consider the wheel. If we balance that wheel at the center, then wheel is balanced here. At that point, wheel is balanced. No wobbling either right or left portion or up and down portion because there's a balance. That point is called a center of gravity point. Okay, very easy concept. There is a center of gravity. Ask you wonder what is center of gravity question. There is a uniform circular motion. There is a force, and last topic here this is called a uniform circular motion, and there is a means a force here. Okay, suppose what someone asks the difference between uniform circular motion and linear motion. Okay, so uniform circular motion where speed and velocity are constant, but acceleration is zero. But in case of circular, linear motion means that the acceleration is zero because the uniformly motion. Acceleration, what is the acceleration? Acceleration velocity change is acceleration. But in that case, here is acceleration is zero. The velocity is constant. That is a uniform circular motion. Uniformly, either fixed at some time interval, some the same distance is traveled. That's called same time interval, same distance is travel is called uniform circular motion. But in case of non-uniform or circular motion, that is important. In case of circular motion, their velocity is change. Okay, velocity is change. Why? Because velocity is a vector quantity and there is a direction in that present here. Okay, so that's why velocity is a variable, but speed is constant. Is always what a difference between uh, uniform circular motion and uniform linear motion. Uniform circular and linear motion. Means in case of circular, velocity is changed because in circle, if body or car is rotated at that point, velocity is tangent. Velocity is tangent. At that point, tangent. So car or body move in anti-clockwise direction. Velocity is tangent. Velocity is a vector. Velocity is a vector quantity. That's why tangent. But in that case, speed, that's only a magnitude, is a scalar. Here only a magnitude. So speed is constant. In uniform circular motion, speed is constant, but velocity change. But linear motion, they all are in constant because they also move the same direction. In that case, we get a two types of forces. Okay, we get a two type of force. If body move, so we get a some inward forces. That force act at the center of gravity or center of a circle. If body path is a circle, center of circle, that force is center seeking force. That force is center seeking is called centripetal force. Because center seeking force is called centripetal force. The body rotate, someone, some person, sting some stone, they are rotate. Stone also rotate. Means there is at that person A gets some force, needed a huge force. If the person is uh, throw that body, if just release that, then object is stone is good like tangentially, either that or that point is go tangentially. You release that point, that go tangentially. If the person is release that stone, that goes tangentially. if that a force, the center seeking force is called a centripetal force. Okay, it is a centripetal force. And that force is called like a sun and earth is also attached. That distance is also a centripetal force attached to that force. Okay, and another type of force is called centrifugal force. Okay, what is centrifugal force? Suppose if body, I will tell that if stone released from here, the body move that direction. So some here force, a body move direction, some direction force, that body move direction, some direction of force, passive force, and we know that from Newton's second law, force equal to mass into acceleration, and acceleration equal to velocity by time. So force is directly proportional to velocity. If more force means more velocity, more speed from stone goes far away, far away. If more force means more far away, if less force means less velocity. And that velocity could tangentially move, that is called a centrifugal force. The name is centrifugal force. Centrifugal force. Okay, and centrifugal force is not a real force. Centrifugal is not a real force. That's a fictitious force. Okay, because if body move that direction is velocity wise, you know the velocity is proportional to force. From Newton's second law, we get know very good. We get a force here. That force is called a centrifugal force. But centripetal force is a real force. What's a fictional force or a virtual force? Another good name is virtual force. Okay. So in class here, there's a chapter 1 concept. If any doubt, put in comment section. I give the answer here. But practice the numerical, very important. Here is numerical is very important. And okay. So we meet a next class. Here next class we discuss the chapter 2, work, energy and power. Okay. Thank you.